So we've got the homework graphing equations. We're going to look at just some specific, graphs. And get out that frame we did. And if you didn't do it, go print off the paper and watch the video and get it. Because that's going to help us with some of this graphing stuff. Okay. So the first types we're going to graph, we'll use the slope-intercept form. Okay. It says either use a table of values or slope-intercept form. I'll do number one, I'll do as a table, just to remind us how to do that, because that's always useful. But then we'll do the slope-intercept form. So when we make a table, okay, we make our chart, sometimes called a t-chart. Look at our variables, x and y. So we need to label our columns the same as the variables. Then we need to pick some numbers. Okay, now, because y is by itself, I'm going to pick numbers for x. And typically I need 3 numbers. And I want to make them easy numbers. So 0 is a definite one we're going to do. Okay, we could also do -1, -2, 1, 2. And I would write them in a pattern. Okay, so like -2, 0, 2. Let's use those ones. So then we're going to plug them into, we're going to put them into our equation for x. So I take my equation, y equals negative, but instead of x, I'm going to put my -2. -1. A negative and a negative make it positive. Positive 2 minus 1 is 1. So y equals 1. Then we do it again for our next number. So y equals, this time we're going to use 0, -0 minus 1. -0 is still 0. 0 minus 1 is -1. So y equals -1. We do it for 2. So -2. And because that negative's on the outside, that's why I always have to include that negative out there. -2 minus 1 gives us -3. There's our next one. Now, once we've got that table, these turn into the points, right? The ordered pairs. So I graph -2, 1, 0, -1, and 2, -3. I've got 3 points. I can see a pattern. Now, if I wanted to, I could find the slope. 1, 2, 1, 2, down 2, to the right 2. And I could keep doing that. Down 2, to the right 2 to make my next point. Or go to the left 2 and up 2. I can use that same pattern, but I don't need to. So, you can use a table like that on any one of them. And if that seems to be easier for you, go for it. Okay. Now, if we're talking about slope-intercept form, remember that's y equals mx plus b, where we've got our y-intercept, where it goes on the y-axis, so a -5 here. We draw our starting point at -5. Then our slope, usually fraction the y value over the x, up or down, over right or left, and ours is 3/2. Positive, positive, positive means up, and positive means to the right. Just like on a graph, to the right is a positive numbers, and up are positive numbers. So I go up, starting at that point, we go up 1, 2, 3 to the right, 1, 2, and we draw our next point. Then we go up 1, 2, 3 to the right, 1, 2, draw our next point. And we can keep going. We're realizing 3 points is definitely enough, and we can draw our graph. And remember this basic idea. That was a negative slope. So notice the shape as we look left to right, it goes down. This was a positive number, a positive slope. So as we look left to right, it goes up. That's kind of a general rule of thumb. Let's do some more. Okay. So 3, y-intercept of -1, start at -1. Slope of -3 over 2. Now, that negative's in the middle. You can do a couple of things. I like to always assume and think of that negative as being with the top. You can assume or think that negative is with the bottom. Okay, doesn't matter, you're going to get the same result. If I think of it as the top, I'm going to go down instead of up, but I'm still going to go to the right. Negative on top means down, bottom still to the right. So I'd go down. 1, 2, 3, 1, 2. Draw my next point. If I thought about it this way, well, then I'd go up 3, but I'd go to the left 2 because it's a negative bottom. Up 3, 1, 2, 3 to the left, 1, 2. Notice, that's still the same pattern, still giving me that line. Now, if we look at number 4, x equals negative 5. Well, that one's different. There's no y in here. When you only have one variable, just graph it on the number line of that variable. So we have x, so go to the x-axis. Where's negative 5? Negative 5's right here. Now, the problem is I can't just put a point. But, because this is also negative 5 for x, this is also negative 5, this is also negative 5. So basically, I need to draw a line there on all those negative 5's, those possibilities. Because all those points on that line have the next value of negative 5. And that's a vertical line. Anytime it's x equals a number, and that's it, that's going to give you a vertical line at the number. Okay? Alright, now number 5 looks like it may be a vertical line, but it's not, because we have a y and we have an x. Okay, the way we think about this one is, couldn't I write a plus 0 here? Yes, I could. So when you don't have anything, think of it as 0, so our y-intercept is 0. Then our slope, 3 over 4, positive, up, positive to the right. So up, 1, 2, 3, to the right, 1, 2, 3, 4. Now it looks like I'm going to run out of space. But because I know that pattern, I can apply that pattern the opposite way. 4 and 3. Because that's up 3 over 4. Same pattern. We can just use that pattern backwards and draw our line. Now we look at 6. Another just x equals. So I go to 1, draw my vertical line. And we call it good. Those ones are nice and easy, aren't they? Alright, 7. We've got another issue with the 0 one, right? So y-intercept is 0. My slope is just 5. It's not a fraction, but we make it 1. Put the 1 underneath. Positive 5, positive 1. So up 5, up to 5, over 1. Or we can think opposite down and to the left. And the reason we can think that is because I could write negative 5 over negative 1. That's the same as 5 over 1. A negative over a negative is a positive over a positive. Same thing. Okay, so we'd move it down 5 to the left 1, right there. So we have this horrible graph. Very steep line. Okay, number 8, now we're back to kind of what we're used to seeing with slope-intercept. Negative 1, y-intercept of negative 1, slope of negative 5/3. So remember, think of it as either negative 5/3 or 5 negative thirds. Never think of it as negative 5 over negative 3. That is not correct. So I can either go down and to the right or up and to the left, and I'm probably going to do both. Down and to the right, down 5, to the right 3, or up 5, and to the left 3. And that gives me my 3 points, and we draw my graph. And slope-intercept form is just this quick and just this easy. That's why we like slope-intercept form. So 6x plus 3. And if you haven't yet, pause it. Try to do 9 and 10 on your own. And then check by unpausing it and seeing how well you did. Find those mistakes. That's how you're going to learn. So plus 3, y-intercept of plus 3. Slope 6. Make it a fraction, 6 over 1. So I could try to go 1, 2, 3, 4, 5, 6 over 1. Or I can go down 1, 2, 3, 4, 5, 6 and over 1. And that gives me a pretty good idea, though that line was totally off. There we go. Number 10. Once again, pause it, try to do it on your own, and see where you get. Negative 3. Negative 3 for my y-intercept. My slope. Notice the slope's always with x. The y-intercept is never with x. And y is always by itself on the other side. So 4/5. We can go up 4 to the right 5. So up 1, 2, 3, 4 to the right 1, 2, 3, 4, 5. Now, if you draw 2 points, honestly, that's enough to make a line. Typically, they like to say make 3 points, but 2 is usually enough because we know these are slope-intercept. We know they're linear. If we didn't know if it was linear, we definitely want to make more points. Alright, 2 more. Try those out on your own first, and then let's take a look. So hit pause, work them out, and now check. Y-intercept is -4, start at -4. Slope of 7 over 4, positive and positive. So up 7, 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Now those are big numbers, so I'm going to say 2 is enough to draw my line. We went up 7 over 4, and we could keep going up 7 and over 4, or over 4 and down 7, but we don't need to. Okay, y-intercept of -4 again. This one's almost identical, isn't it? Slope of 7 over 3, so up 7, to the right 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, which they almost look identical, don't they? Because their slope is only slightly different. Alright, now 13 looks crazy. 14, we know how to deal with that. X equals 5. Go to 5, draw that vertical line, call it good. Now 13, y equals x. Okay, we could say plus 0, so my y-intercept is at 0. Now the slope, whenever we don't have a number in front of x, we can always put a 1 there, because 1 times anything stays the same. And to make it a fraction, we can also put 1 on the bottom. So we go up 1 over 1, up 1 over 1, up 1 over 1. So we're making some really nice stairs here. Okay, Minecraft style, 1 box at a time, right? Okay, now this graph actually is a special graph. Okay, for all linear graphs, this is the parent function. And when I say parent function, it's the function that all graphs that are linear are based off of. Okay, just a little information. You'll talk more about that in the next years. Alright, now 15. 15 kind of looks like 14, doesn't it? We've only got one variable. This time it's the y variable. Now, just like on the x variable, we graphed on the x-axis. On the y variable, we're going to graph it off the y-axis. So I go to y equals -3 down here, and all these points here have y values of -3. So we draw ourselves a horizontal line. So if it's y equals a number, that's going to be a horizontal line at the number. Okay, now number 16. It just gave us an x-intercept and a y-intercept. Remember, intercepts are where it crosses an axis. Okay, so x-intercept crosses here. Y-intercept crosses here. So it's going to give us 2 points. And now it just gave us a number. But anytime you have an x-intercept, it's always going to be that number, comma 0. Because any point on the x-axis has a y value of 0 because it's not moving up or down. Okay, so I go to 2, 0, draw my first point. Now my y-intercept is the same idea. It's 0 and then the number, whatever number is the y-intercept, because any point on this y-axis is 0 for the x value. So the y is up to 3. Now I've got those 2 points. If I wanted to, I could find the slope, right? Down 3 to the right 2, down 3 to the right 2. But I don't necessarily need to do that. But if you really wanted more points, you could use 2 points to find the slope, and from that, draw your line. And we use that idea for these ones. Okay, these ones are called standard form. They're standard form because they have the x and the y on the same side. So what you want to do is actually find these guys, the x and y intercept. And because the x-intercept has a y of 0 and the y-intercept has an x of 0, here's how we do it. We get our equation, And to find the x-intercept, I'm going to keep my x and make my y 0. It's almost like we're making a small table. And we're saying, what is y if x is 0? What is x if y is 0? So I plug in 0 for y first to figure out this first point, this x-intercept. So we get 2x equals 4, divide by 2, and x equals 2. So, I think I told you the wrong one first. This one right here, the y-intercept first. Yeah, this is how you find the y-intercept. Sorry. No, the x-intercept. Whoa. Hold on. I'm getting all mixed up. I was right. It's the x-intercept, but it's this point is the x-intercept because the y is 0. That's where I made my mistake on my little table. So, 2, 0, there's our x-intercept. Now, to find the y-intercept, we do the same thing, but this time we make the x 0, and we solve for y. Okay, in our table. Now we're doing that one. There we go. 2 times 0 is 0. 0 plus y is still y, so y equals 4. So there's our 2 points. There's 2 points. Yes, I could go 1, 2, 3, 4. It's down 4 to the right 2. So I could go down 1, 2, 3, 4 to the right 2 to continue that if I really wanted, but I don't need to. Okay, those 2 points are enough. Alright, so let's take a look at that again. So anytime you're given this standard form, this works really well to figure it out. So, right, it's like we're making a mini table where x is 0 and y is 0. So for that x-intercept, we keep the x and we make the y 0. Okay, so negative 2 times 0 is still 0. So we get x equals negative 2. So there's our x-intercept. So negative 2, there's our x-intercept. Then we do it for the y-intercept. So we make x 0. Now remember that minus 2, that negative has to stay with the 2, even though that 0's, we're getting rid of it. Divide by negative 2. Negative 2 divided by negative 2 is 1. So our y-intercept is at 1. We could, yes, find our slope and keep using that over 2 up 1, over 2 up 1. But we don't need to. 2 is enough to draw. Okay, that's how we use standard form. Now, if you look at these next two, you may think they're standard form, but they're not necessarily standard form just based off of looking at it. Okay? Because, yeah, the x and the y are on the same side, and I could add 5 and get it over to the other side. That would work. Okay, that's one approach you could take on this one. I could add 5, and then I'd have 5 equals negative 2x plus y, which I can change the order because it's around an equal sign, and I could go negative 2x plus y equals 5 if I wanted to. If you felt more comfortable that way, that would work. Okay, you could also subtract the y on both sides and get negative y equals negative 2x minus 5, and then divide by negative 1 to get y equals positive 2x plus 5, and you could do it slope-intercept form. You'd get the same exact answers. Okay, y-intercept of plus 5, slope of 2 over 1, so up 2 to the right 1, or down 2 and to the left. Okay, you could get it. I think that's probably the easiest way to do it. But we could also have done the same thing with x and y intercepts. You know, keep the x, make the y 0, divide by negative 2. So we'd get 5 divided by negative 2 is negative 2.5, which basically looks like that's where our x-intercept is. Then do it for the y. Negative 2 times 0 plus y equals 5. That would be 0. 0 plus y equals 5. Y equals 5, which we said was already the y-intercept. X and y-intercept, we draw the same graph. So it works either way. Or, if you don't like manipulating that, you could have made a table of values. So on this one, I'm obviously showing you 3 ways that you could do this problem. So if we did a table of values, x, y, pick some easy numbers, -1, 0, 1, plug them in. So we get 0 equals -2 times -1 plus y minus 5. -2 times -1, positive 2, plus y minus 5 equals 0. 2 and 5 we can combine. 2 minus 5 would give us -3, plus y equals 0. Add 3 to both sides. We get 3 equals y. So at -1, our point is up to 3. Okay, same point, same line. Because when you do it that way, it doesn't matter which method you use, you're doing the same process, finding the same points. Then if we did 0, -2 times 0 is 0, y minus 5 equals 0, add 5, we have 5 equals y. There's our y-intercept. If we did it for 1, -2 times 1 plus y minus 5, -2 times 1 is -2, -2 minus 5, -7 plus y equals 0, add 7 to get the y by itself, 7 equals y, 7. If we went up 1, 7 is where we'd end up. Okay, so either method works there. Either method works. You get to choose it. It's what you feel more comfortable with. Now with 7, or 20, we've got 7x equals 12 minus 3y. We can do the same stuff. Okay, it doesn't really matter which one we choose to do. Just for the purposes of showing you one more table, I'll do table since we've done a lot of the other ones. So I'd make my table, x and y. Now, I would probably like to use the y to make it work, because I think it might be easier to put those numbers in. Okay, but if I do that, I'm going to have to divide by a 7. So that can make it a little more difficult, because when you divide by 7, that's kind of tough. So which numbers, do you want to choose? That might be a little tricky. Okay, so because I could pick numbers like -1, 0, and 1. Let's see what we get. Plugged in -1, 12 minus, or -3 times -1 would give us +3. 12 plus 3 is 15. 7x equals 15. Divide by 7. X would equal 15 over 7. Well, 7 can go into 15 twice, right? 2 times 7 is 14, and you'd have 1/7 left over. Okay, that's not the nicest number, but we could graph it. We'd go to 2, a little past 2, and down -1, because 1/7 would be a very small decimal. And you could figure it out with a calculator and be a little more accurate. That works. Is it our best, easiest way to do it? Probably not, but we can do it that way. So 0. -3 times 0 would give us 12. Divide by 7. X would equal 12 over 7, which 7 goes into 12 once, and there's 5 left over. Now 5/7 is almost 7/7. So we'd go to 1 and a little past it, and so it'd be something like that. Okay. And then if we did 1, 3 times 1, 12, 7x. That'd be 12 minus 3, which would be 9. 7x equals 9 divided by 7. We get x equals, 7 goes into 9 once with 2 left over. So that's a little further than 1/7. So we'd go 1 2/7 and up to 1. So it'd look like that. So our graph would look something like that. Okay, that works. Now, is it the best route to go? Probably not. Sometimes tables are harder to do, and it's probably because we could have picked better numbers and we would have got the same graph. Honestly, probably a better idea here would be to do something like, you could add 3y to both sides, and you get 7x plus 3y equals 12. then you could do the x and y intercepts. Okay, or you could have went like this, tried to get y by itself. You could have subtracted 12 and got 7x minus 12 equals negative 3y. Divide by negative 3 on everything. You get negative 7 thirds x. Negative 12 divided by negative 3 plus 4 equals y. And that's basically slope-intercept form, isn't it? Put the equals y on the other side. So our graph should have went up a little more, shouldn't it have? Start at 4, go down 7, to the right 3. So there's multiple ways to do those. Alright, so let's finish this off. We've got less than 5 minutes. Alright, so make a table and graph to match each story. So, let's start with a table. Albertimus is looking into adding to his Unicorn Patrol collection. He currently has the original 5, but since the show has ran through many different Unicorn Patrol members, he's looking to collect them all. With his allowance, he figures that he can buy one every 3 years. Okay, so what groups do we have? Well, we've got Albertimus. He's got a collection, right? He has 5 of them, looking to get more, and he has money, right? And years. So, he's got 5, right? And what is he looking? He's looking to get more of them. So our groups are probably going to be having to deal with number of ponies, right? Unicorn Patrol. Why did I say ponies? Let's say UP, Unicorn Patrol. And he's going to only be able to get more every 3 years. So we're going to have time. We're going to have years. Okay, those are our 2 groups. So the relationship is that he can get one more every 3 years. So how many did he start out with? Okay, what's the start? Before he started saving his allowance for that, before any of those years had elapsed, he had the original 5. Then every year, well, not every year, actually, every 3 years, right? Every 3 years after that, he's going to be able to buy one more. So every 3 years, we can buy one more. So here's the pattern. Okay, so now we can graph that. So here's our axis for the x, axis for the y. Now we'd probably call this one years. We need to label them. And this one, Unicorn Patrol members, how many he has, right? So we started out at 0, 5. So let's count 1, 2, 3, 4, 5. So 0, 5. So there's 5. Then every 3 years, so 1, 2, 3, he goes up 1. 1, 2, 3, goes up 1. 1, 2, 3, goes up 1. Okay, so we can see that pattern. 1, 2, 3, goes up 1. 1, 2, 3, goes up 1. And there's our graph. Okay, now, write an equation. Well, we kind of think about that slope-intercept form, y equals mx plus b. Do we have a y-intercept? Yeah, it's 5. Do we have a slope? Yeah, up 1, to the right 3. So up is the y over x, so 1 over 3. So we could write y equals 1 over 3x plus 5. There's an equation right there. Alright. Last one. Sorziana is saving up for college. She already has $2 in her bank account. Her job pays $10 per week. And we're, I guess, assuming that she'll probably put that money in. So money in bank account would be one group, right? And I'm almost out of time. I only have 30 minutes. And then time, again, right, per week. So you'd make a table. You've got the weeks and money. So she started out with $2. And every week she gets $10 more. 32. Okay. So then you'd graph that. And I'm going to run out of time probably. But 0, 2, you'd start out down here. And then for every week she'd go up 10. So, you know, something like that. You'd have to fill in the numbers. So that should be 10, 12. That should be 22, and so on. Okay. And then same idea. Y-intercept, where did she start? She started at 2. How's it growing? We're going up 10 for every 1 week. So 10 over 1 or just 10. Alright, there you go. Goodbye.